In this problem, we have two cars, A and B, which are initially next to each other at the origin at rest, and they begin accelerating with different accelerations and stop at different times and velocities. And we want to know what the acceleration versus time, velocity versus time, and the distance versus time graphs look like. So first for the acceleration versus time graph, this is most straightforward for A. It's initially at 4 meters, so 4 meters per second squared. And it's like that for 10 seconds. And then it maintains a constant velocity. So the acceleration is then 0. For B, it's at 5 meters per second squared. 5 meters per second squared. And it does this for some amount of time, which we'll figure out right now. So it is accelerating at 5 meters per second squared and has a final velocity of 25 meters per second. So we know that v is equal to v naught plus acceleration times time. The initial velocity is 0, so we can just plug in our final velocity of 25 meters per second, which is equal to our acceleration of 5 meters per second times the time, and we find that the time is just 25 over 5, which is just 5 seconds. So this should be a half as long as A is accelerating for. So that's 5 seconds. And then again, it's just 0 because it is maintaining a constant velocity. Next, we want to know what the velocity graphs look like. So we know what the slope of these are going to be initially because the slopes are going to just be equal to the acceleration. And then once they're done accelerating, they're going to be a flat line since they're maintaining a constant velocity. We'll do B first since we already know what the final velocity is going to be. So for B, we're going to have some line. And this line is going to be such that the final velocity is 25 meters per second, and the time at which this occurs is 5 seconds. And then after that, it's going to be a straight line. So that's what B will look like. And for A, why don't we go ahead and find the final velocity using this equation. So we know the acceleration and the time, the initial velocity is 0. So like we did last time, v equals at, which is just 4 times 10, which is 10, which is just 40 meters per second. So A, it's going to have a more shallow, or it's going to have a less steep line than B because the acceleration is lower. So it's going to look something like that if we can draw a straight line. And these are should both be starting at the at the origin. And then we'll pretend this is on the axis, but this is going to be 40 meters per second. And the time, which we'll again pretend is on the axis, is going to be at 10 seconds. And then after that, it's going to be a straight line. Now, the last part of this problem is what does the position look like over time? So what broadly is going to happen is they're accelerating initially, so they'll have some like parabolic shape like that, and then they have a constant velocity, so then they'll just be a straight line. So blue, since it has a steeper acceleration, is going to look like this, and then it's going to have some constant velocity like that. It's going to go off into space. And red is going to have a more shallow parabola since the acceleration is less. And it's going to reach going to be going for longer. And then it's going to have a higher speed then. So it's going to be a straight line after that. That's going to be steeper than blue since the final velocity is greater. And if we say this is around where it stops, or I guess maybe this is around where it stops accelerating. So this is 10 seconds where it stops accelerating. And for blue, where it stops accelerating is 5 seconds. And we want to know, in addition to this, what the distance between the cars is when t is equal to 15. So t equals 15. So that's somewhere over here. So what we can do for this is we can use the equation that the change in the distance is going to be the initial velocity times time plus 1/2 of the acceleration times t squared for an constant acceleration. And then after that, the change in distance is just going to be the velocity times the time. So we can add those up then to get the total distance changed for both of them. So we'll start with A. So delta S, the initial velocity is going to be 0. It's going to be 1/2 times 4 times 10 squared plus a final velocity of 40. And this is going to be for until t equals 15. So 15 minus 10 is 5. So plus 5 times 40. So delta S for car A is 1/2 times 4. So that's 2 times 100 plus 5 times 40 is 20 times 10 is 200. So this is 2 times 200, which is just 400 meters at t equals 15. And for blue, delta S is 1/2 5 times the time it's accelerating for, which is 5 seconds squared, plus its final velocity of 25 meters per second times the time that it's going that velocity, which is 10 seconds. So that'll give us 5 cubed is 125, so 125 over 2 plus 250, which we can simplify this as 125 over 2 is 50 plus 25 over 2, which is 12.5 plus 250. So this is going to be 300 plus 12.5, which is just 312.5. So that's our answer for delta S. And finding the difference between them is just 400 minus 312.5, which is going to be 312.5. Those are gone. Get a 10 there. That's a 9. That's not a 9. This will be n 8. This would normally be an 8, but we need a 7.5. So the distance between the two is 87.5 meters. And that's the solution.